Now then, in this lesson we'll be looking at FMOD's Snapshots feature, what it is, how it works, and most importantly, how we can utilize them in Unity games. We'll be using these snapshots to explore a few different ways we can create zones in our game that apply a reverb to all of the sound effects heard whilst the player is inside them. We'll also look at a common technique used in a lot of games that uses the audio of the game to communicate to the player that they're low on health. Simple enough stuff, so let's make our way over to our FMOD project to set up our first snapshot. So in FMOD, let's make our way over to the mixer window, and this is where we're going to be creating our snapshots. So in FMOD, a snapshot is a state we can trigger in-game that can alter the overall sound of our game by adjusting the levels of our buses and changing the properties of any effects added, and etc. And these changes are usually made temporarily to affect multiple buses and by extension, events at once. We can create a snapshot by opening up the Snapshot tab at the top here in the left, and if we right click, we get the option to create either a new overriding snapshot or a new blending snapshot. We also get the option to create a new group, which helps for organizing our snapshots and giving them priority over others. So the two types of snapshot, overriding and blending, refer to how they will collectively affect any changes made to the levels of your buses if activated at the same time in game. If you make any changes to the levels of your buses using an overriding snapshot, those changes will be applied as you told them to. So for example, let's say we were using two overriding snapshots at once. Both of them will set our sound effects bus to -10 decibels. This would mean that the final level of our sound effects bus would be -10. However, a blending snapshot actually adds the changes you make onto any other snapshots that are also active. So for example, if we started with an overriding snapshot that would set our sound effects bus to -10, then followed it up with a blending snapshot, which we told to do the same thing, the first would change the fader from 0 to 10, but the second, the blending, would actually add a difference of -10 dB on top of that, making our new level -20. Now these concepts are not vital for us to know in order to get the basics of implementing them down, but if you'd like to learn more about how snapshots work together, there will be a link to some further FMOD resources under this lesson. Right, so we're going to start by creating an overriding snapshot. We're going to call it Reverb Zone 1, and we'll be using this snapshot we've created to adjust the level of the reverb return bus to add reverb to our sound effects when this snapshot is activated in game. Now in the first lesson of this module, we looked at what a group bus is in FMOD and how it is used alongside other buses and events. But now it's time to take a quick look at the other type of bus, which is the return bus. Now when a signal is sent to a group bus, only one signal is sent directly into the bus that is then processed and sent onwards. However, whenever a signal is sent to a return bus, the original signal continues on its original path, and in its place, a second is created and sent through the bus to be processed. We also send signals to return buses slightly differently. Instead of organizing our events and buses as children of the bus to send their combined signal into, we instead add a send onto the output of a bus or event. Now first, before we interact with our buses, you're going to want to go to your Snapshots tab and just make sure you don't have a snapshot selected. As you can see, I do, because it's highlighted yellow, so I'm just going to click anywhere away from it in the tab, and now it's highlighted grey, meaning it's not selected. And I'll explain why this is important a little bit later on. So back to our routing tab. We're going to want to select the sound effects group bus, and then to the right of its output volume dial, we're going to want to right click, go add send, and then choose the right return bus, which for us is reverb. Once you've done that, you're going to want to make sure that your send itself is set to 0 dB, so just turn that up. We now have a signal from our sound effects bus going to both the master bus and the reverb return bus. However, seeing as we don't want to reverberate our sounds constantly, whilst our game plays, we'll turn the reverb fader down just to start with to -infinity. Going back to our snapshot now, we're going to want to select it. And what you should notice from selecting it is that all of the fader markers have now been replaced with a yellow outline of where they were left. Now this means that these faders are currently scoped out of our snapshot, meaning they won't be affected by it. To scope a fader in, we simply click on it. So for example, let's click on our return reverb fader. And now you can see it's returned, meaning it's scoped in. It also means that when our snapshot is activated in our game, the level of the fader will be set to whatever value we leave it at. Now, since we want to trigger this snapshot to activate whenever the player should be hearing reverb, we want to turn this fader up to about 0 dB. We're almost ready to jump into Unity, but the last thing we're going to do is add an AHDSR modulator to the snapshot so that all the changes it makes fade in and out as they're activated. Interestingly, snapshots behave and are treated in a similar manner to events, where we can add modulation parameters and tell them to start and stop playing. So to add a modulator, we need to have our snapshot selected, and we want to right-click the intensity dial in the bottom right corner. We want to go add modulation and select AHDSR. Now the intensity dial works kind of like an on-off switch for our snapshot. When it's at 100%, it is on fully, and off fully at 0. Anywhere in between will apply and scale any scoped in faders appropriately to match the percentage. So by applying a modulator, we'll be fading the intensity of our snapshot from 0 to 100 as we activate it, and from 100 to 0 when we deactivate it. Great, we're all set up now. Let's just save our project, build our banks, and we'll head over to Unity. So now it's time to set up our reverb zone, which will, when our player enters, activate our snapshot, turn our reverb return bus fader up to 0 decibels, and reverberate all of our sound effects. Now we're going to make our way over to the second scene of our game to do this, as there are a lot more caves and tunnels that will benefit from a reverb zone. So let's go Assets, 3D Game Kit, Scenes, Gameplay, and select level 2. Once you're in the scene, double click on the Ellen game object so we can be brought to her location. Now, as you can see, at the beginning of the scene, the first thing our player will encounter is a small little tunnel. Well, this is where we will be adding our first reverb zone to. The first thing we need to do is create a new game object, which we'll use as a trigger zone, like we did in the first lesson of Module 2, to turn our snapshot on and off whenever the player enters and exits the area. So let's create a 3D cube object, and then we're going to call it reverb zone. Then, in order to cover our entire tunnel, we're going to set the position coordinates of this object to 0, 0, and 46. We're then going to adjust the size or the scale of it to 11, 8, and 23. Last thing we need to do is move our way down to the box collider component and just tick the is trigger box. Now obviously we don't want our player to be able to see the cube in the game, but for the sake of demonstrating our zone, I'm going to leave my cube like this as a big white visible box. If you do wish to hide your reverb zone, all you need to do is simply remove the mesh renderer component, which is this one here. So if I right click it and click remove component, the box becomes invisible. Great, so once you've got your area set up, you can go ahead and create a new script for your game object and attach it. I'm going to do the same, and once we both have our scripts attached, we can start implementing our snapshot. So as I mentioned earlier, FMOD snapshots are treated like their own events in the mixer. Now luckily for us, they're also treated like events by FMOD Studio API. This means that we can create an event instance variable, store an instance of our snapshot inside of it, and then play and stop it just like we would with any other event. So let's start by creating for ourselves an event instance variable. I'm going to call mine reverb. Next, in the start function, we're going to store an instance of the snapshot. Now inside the brackets, we'll write the path to our snapshot in FMOD. So inside quotation marks, we'll start by writing the word snapshot instead of event, add our colon and /, and then the name of our path. Now in the same way that we must include parent folders of any of our events when writing out their path, we must also write the name of any parent groups we added our snapshot to. Now as you can see, our snapshot is on its own, so we only need to write out its name in our path. So let's write reverb zone 1. Next we need to tell our snapshot when to start, and as I mentioned earlier, we'll be doing this by using our trigger area, so we'll need to use the onTriggerEnter function to do this. I'm going to create mine by writing onTrigger, and Visual Studio's IntelliSense feature actually suggests the function for me, so I'm going to click on that, and with that it actually adds a parameter variable of the collider type, which is handy because that's what we need. So now we have our function, let's add an if statement to it, checking to see if the collider component of our game object ever enters our area. Now in a bit, we will also be using the onTriggerExit function with the same if statement, and normally we could check for the name of our game object entering and exiting the area in this statement, but instead we're going to quickly create a private game object variable at the top of our script in our class, call it player, and check for this variable instead of a specific string in 2 different functions. This is just to simply save our script from doing a little bit extra processing by telling both functions to check a variable that's holding the correct data, rather than each of them to search for that data separately. So in our start function, let's write the name of that variable and set the reference to our LN-game object by writing GameObject.find with 2 brackets, and then writing the name of the object we're after as a string. Now, once the condition of the if statement is met and our player is inside the area, we can tell our snapshot to start by writing the name of our event instance variable and writing start just like we would with an event. Now, as I've just mentioned, we also want to do the same thing with an onTrigger exit function with the exact same if statement. But this time we're going to want to tell our snapshot to stop. Remember, because we added an AHDSR modulator to our snapshot's intensity, we'll probably want to tell our code to allow it to fade out. So inside the parameter brackets of the stop command, let's write fmod.studio.stopmode.allow fadeout. The final thing we'll add is an onDestroy function in which we will tell our snapshot to release. And that's everything we need. So let's save our script, jump into Unity, and wait for it to compile. So before we test this in our game, we're going to actually use Ellen's footsteps to measure whether or not our reverb zone has worked. So before you start your game, just select your Ellen game object and just make sure you've got your f_player script attached to it. In my case, I don't, so I'm going to quickly hit add component and select f_player. Then you're going to want to set the layer masks, which will be environment and as well as water geometry. Then once you know you're going to have footsteps playing in your game, you want to go back to your reverb zone game object and you're going to want to change the layer from default to environment. As we learned back in the play one-shots lesson, we learned that Ellen, who is part of the player layer, can interact and collide with anything that is of the environment layer, both of which were set to be compatible layers in the layer collision matrix. So let's select environment and let's play our scene. Once you're in your game, the first thing you're going to want to do is open up your audio settings menu and just turn down the music so that we can focus solely on the sound effects. Then you can quickly test you've got your footsteps playing, which we do, and then we're going to walk into the trigger area and we should see or hear the footsteps are now reverberated. We then leave the area, they return to normal. So that's one way to use snapshots and create reverb zones. We're now going to look at another to demonstrate another way you can control a snapshot's intensity. First, let's go back to our snapshots tab and we're going to copy the first snapshot we made earlier. I'm just going to paste it back in and we are going to call this new one Reverb Zone 2. So just like how we can use modulation to the intensity of our snapshots, we can also automate them with parameters. This gives us more variation over how intense our snapshots effects can sound in game and makes them feel less like an on and off switch and a little bit more dynamic. So to start, with the Reverb Zone 2 selected, we're going to remove the modulation that is attached to the intensity wheel by right-clicking and selected remove all modulation. Then we're going to right-click it and select add automation. This gives us access to an automation section where we can click add curve and choose an existing parameter to control the dial with. Now we could choose one of our existing parameters we created for our events, but we'll be using FMOD's pre-programmed distance parameter just as we did in our first parameter lesson. So as we already know, this will automatically calculate how close the FMOD Studio listener component is to the location of our snapshot instance in Unity, which we can then use to automate the intensity of it. Now what's good about this method is that we can now design the roll-off of our snapshot ourselves, allowing us to set the distance that starts and fades out our reverb rather than setting it to do it over time. So for the area we're going to be testing this in, I know that we roughly want to set ourselves a minimum distance of around about 5 and a maximum distance of about 10. So I'm just going to leave mine like that. So if our player is anywhere between 0 and 5 units from our snapshot's location, the reverb fader will be at 0 decibels. Anywhere between 0 and 10 will cause the fader to drop between 0 and minus infinity dB. And finally, if they are 10 units away or more, the fader will be at minus infinity, meaning no reverb will be heard. So let's save our project again, let's build our banks and jump back into Unity. Okay, so we're going to create another object. This time it's going to be an empty object. We're going to call this one Reverb Zone 2. We're then going to set the position of this object to -1, -3, and 28.5, which will center the object in the starting area of this scene, which will be the area we'll be adding reverb to. Once you've done that, in your FMOD folder, go ahead and make yourself another script for you to create your snapshot with. Once you've created your script, go ahead and attach it to the game object we just created. So now that we're in our script, we're going to start this one off by adding our 2 FMOD namespaces to the top of our script. Then we're going to create another event instance, and we're also going to call this reverb. Now, just like with events, we can also use public strings to select our snapshot from FMOD in the Inspector tab of Unity. So we're going to create a public string, call it snapshot. We're also going to add the event ref attribute as well. And notice how, because we're using our FMOD Unity namespace, we only need to write event ref. So now when we create our instance of this snapshot, we can use that string variable. Then we'll quickly save our script, jump back into Unity, and on our script that's attached to the Reverb Zone 2 object, we're going to search for our snapshots under snapshots and select Reverb Zone 2. So now that our snapshot instance variable is ready, it's time to think about how we're going to trigger our snapshot to play. Now, unlike last time, we want our snapshot to be ready and playing as soon as our scene starts, so we won't be using a trigger area to start and stop it. We also need to treat our event instance variable as if it were a 3D event, as our distance parameter will need to track the location of where the reverb will be played from to calculate the intensity automation we added earlier. So we'll start by using the start function to tell our reverb to start. Next, we're going to use the attach instance to game object command to make our variable 3-dimensional. We're going to play it at the location of our game object. We're also going to look for a rigid body if there is one. We'll also add the release command as well to release the instance once it's stopped and finished with. We'll also quickly create an onDestroy function, which we'll use to tell our snapshot to stop when the object is destroyed. Notice, however, that when using stop mode, we're still using the fmod.studio namespaces. Unfortunately, we still need to use these namespaces for the stop mode enum to work when we pass it through parameter brackets, so make sure to add them. We'll also be using immediate this time as opposed to allow fade out, seeing as the instance will be stopped when the scene is finished and the object is destroyed. We don't need to fade it out at all. And that's pretty much everything we need to do with our script. So let's save it, jump back into Unity, and let's give it a test. So now that we're in our game, let's quickly turn down our music one more time. And let's walk around and see if we can hear our footsteps reverberated. There we go, so just like last time, they're echoed. Now if we run a little further away from the center of this circle, the reverb's still there, but it's not as strong. That's where we faded it out. We're using the parameter. And if we enter back into the center, it comes back in and it's a lot more stronger. Now, one other way you can interact with your snapshots in C# is actually by exposing the intensity dial itself as a parameter, and then setting the parameter to interact with variables in our code. Now, to look at how we might do this, we're going to set up a new snapshot that will filter our sound effects bus so that we can only hear the low frequencies when our player has taken enough damage. So to start this off, without selecting any of our previous snapshots, we need to select our sound effects bus. We actually need to come down to the effects channel, right click, go add effects, and select the FMOD free EQ. Now notice how currently the EQ comes after our send to the reverb bus. Now it's important to consider what order you're putting sends and effects in for you to get the correct sound you're after. Currently, as we learnt earlier, if the player walked into a reverb zone, a dry signal would be sent into the master bus, but another would be sent to the return reverb bus, reverberating all the sounds, and then finally sending that to the master bus as well. So if our player took damage whilst in this zone, causing our sound to be filtered, which is the effect we're about to apply, we'd only be filtering the dry signal itself that wasn't sent to the reverb return bus. This means we'll be hearing one signal with just the filter effect applied as it's sent from the sound effects bus straight to the master bus. We then also hear another signal with just the reverb applied as it's sent to the reverb return bus and then to the master bus. Now, to make the effect of the player sustaining damage more impactful, we want to move our EQ in front of our send, so that now, before our original signal is split into two, the filtering is applied, meaning that the return bus will only have low frequencies reverberated. So now that we've done that, let's go back to our Snapshots tab and let's create a new overriding snapshot, and we're going to call this low health. Now, whilst the snapshot is selected, let's apply the desired effect we're after, which is turning down the high band and the mid band of the EQ so that we only hear the low frequencies. Next, let's right-click on our intensity dial and select Expose as Parameter. By doing this, we've created a brand new parameter with the same name as our dial, which we can see at the top here. By doing this, if you also open up the Automation and Modulation tab, you can see how the parameter now controls the intensity we hear of our snapshot, meaning that when it's set to 100 by our code, we'll hear our filter effect at its fullest, and we won't hear it at all when it's set to 0. Now, we're going to be using this parameter to mimic the value of our player's health, which can be anywhere between 0 and 5. Therefore, it makes sense for us to come up to our intensity parameter, right-click it, select Edit Parameter, and then just change the range from 0 to 5. Then hit OK and select Scale. Next, we need to edit the automation graph itself. Currently, our dial is set to play our snapshot at full intensity when our parameter is at 5, applying our filter effect. And because we only want to hear our filter effect at a maximum intensity when the player is at 1 health, we're going to want to set some new values for this graph. So let's say that between the values of 5 and 3, the intensity of our snapshot will be 0, and our player won't hear any effect to the sounds. Then when it's at 2, we'll set it to about 50%, so they start feeling the effect. Then finally, when the player's health is at its lowest of 1, we're going to set the effect to 100%. And we'll do the same when the health is at 0. Seeing as shortly after the player hits 0 health and dies, they'll be respawned back at 5 again anyway. We also want to make sure that we set our parameter's initial value to 5, so that when the player starts the game at full health, they won't hear the filter effect. So let's set the parameter to 5, right-click it, and select Set as Initial Value. And the last change we'll make is to select the parameter itself and adjust the seek speed value to about 1.5 per second, as this will fade the parameter between values slowly rather than forcing it to jump between them. And with that, our new snapshot is good to go. So let's quickly save our script and build our banks. Now, before we edit our scripts, I'm going to quickly show you a new event I've set up for us to hear the effects of our new snapshot just a little bit easier. Now, as you can see in my sound effects and Ellen folder, I've created a new event called Ellen Grunt, which will play a cry whenever our player takes damage. As you can see, this is a simple 3D event that uses a multi-instrument to play one of the many Ellen Emote Takes Damage files. You can find these files under Assets, Ellen, and Damaged. So feel free to quickly make this event yourself, save your project and build your banks again if you wish to hear the snapshot just a little bit more clearly. Now that we're back in Unity, we're going to be triggering both our new snapshot and our new event by using the player controller script that's attached to Ellen, which we've looked at before in the interpreting code lesson. So once you've selected Ellen and found the player controller, right-click it and select Edit Script. So we're going to start inside the player controller class by creating a new variable for our snapshot called filter. Once we've done that, we need to give this script a start function because it doesn't actually have one. So let's write void start, add parameter brackets, and give it a body. We'll then create an instance for our snapshot inside this start function, which will look like this: snapshot : /low health. We're also then going to tell it to start the snapshot and release it once we're finished with it. We'll then also create an onDestroy function, which we'll use to tell it to stop. We'll also tell it to stop immediately as well, as we won't need to fade it out. Okay, so to quickly recap, inside our player controller script, we're declaring a new event instance variable, holding an instance of our low health snapshot. Whenever a scene starts with our player in it, on the first frame our snapshot will start and be ready to be adjusted. Then once the Ellen object is destroyed, so will our instance. Great, so now it's time to look at how we're going to change our snapshot parameter and call our new event. Now if we scroll all the way down to the bottom of this script, we'll find a function called damaged. Now, Ellen has another script attached to her called damageable, which monitors her health and detects whenever she has taken a hit. Whenever she is, a message is sent to this script and a damage function is called, making it a perfect option for us to play our audio with. First, we're going to create a one-shot to play the grunt event. So at the bottom, let's write FMOD unity.runtimemanager.play one-shot attached. Add the event path for our grunt event and tell it to play at the location of this game object. Now it's time to set our intensity parameter we created earlier to a variable that holds our player health, as this value will determine what value our parameter will change to and how our snapshot will affect our audio. To do this, we're going to quickly go back to Unity, and we're going to open up the damageable script attached to Ellen that we just talked about. Then right-click it and select Edit Script. So as I just mentioned, this script is what controls our player's health and damage during the game. Now we can already see a few variables that would help with this, such as max hit points and invulnerability time. Well, the variable we're after is the one called current hit points, as this will hold the value of our player's health at any given moment in the game. However, we want to be able to set this variable to our parameter within the player controller script's damage function, which is obviously called whenever our player takes damage. And the reason why we don't want to do it inside this script is because other game objects in our game, such as enemies and bosses, also use the damageable script to calculate their health and damage. We only want to set our parameter values when the player takes damage. So if we edit this script to change our snapshot's parameter, it would change for all other damageable objects in our game. Therefore, we're going to need to pass the current hit points variable from the damageable script that's specifically attached to our player controller script. So let's jump back into the player controller script and do just that. So inside the damaged function, we are going to write the name of our variable holding our snapshot. And we're going to use set parameter by name to set the intensity parameter we made earlier. Remember, if you're using a version of FMOD older than version 2.0, you'll want to instead write set parameter value. Because I'm using 2.0, I'll be using by name. So inside parameter brackets, we're going to write the name of our parameter, which is intensity. And then next to it, we want to set the parameter to the current hit points variable, which we want to get from our damageable component attached to the Ellen game object. So because this script, the player controller script, shares the game object, we're going to write get component damageable. Then using the dot operator, we want to follow it up with the variable we're after, which is current hit points. Now we can even shorten this a little, as the player controller script already has a reference variable set up for the damageable script component attached to Ellen. So let's see if we can find it by hitting Control F and writing damageable, then pressing the white arrow until we can find a variable. Here we go. We can see that this is the variable here, as it's using the reference data type damageable, and it's called itself m_damageable. If we hit the white arrow again, we can see that on the enable function, the variable m_damageable is getting the component damageable. So all we need to do is use this variable in place of get component damageable. So back in our set parameter by name command, let's replace this section here, get component damageable, with m_damageable. Just like that. Finally, we need to decide whether or not we're going to ignore the parameter's seek speed. Now, obviously, because this time we actually gave it a seek speed value of 1.5 per second, we definitely don't want to ignore it, so we're going to write false. Again, if you're using set parameter by value, you don't want to add that boolean at the end. You just want the name of your parameter and the variable you'll be using to set its value. But either way, now whenever our player takes damage, this function will be called. Play the grunt sound as a one-shot, and then set the value of our activated snapshot to match the new value of the current hit points variable of our player. Now the last thing we want to do is set the parameter back to its max value whenever our player has died and respawned. And to do this, all we're going to do is copy our set parameter by name line by hitting Control C or Command C. Scroll down to our die function, and at the bottom, just paste it in. We also now don't want to check the value of our player's current hit points, as we now want to make sure our parameter is set back to its max value of 5. So let's instead delete this section here and replace it with a float value of 5. And with that, we are finally all set. So let's hit Control S to save our script. We can finally jump back into our game to test it out. So once we're in our game, let's get into our audio settings menu and once again turn down the music. Now we want to find some enemies so that we can test to see how well we take damage and hear the effect. So if we run forward, we should find a little room with some chomper enemies in. Here they are, so go ahead and take some damage. There you go. You should hear the grunt effects play. Now keep taking damage until you get to about 2 hearts of health. Now if we run around, our footsteps should sound slightly more muffled. Then on 1 health, they should sound really muffled. And then when we die, the effect is reduced and our sounds are playing normally again. Great, so everything works perfectly. And that's everything. We now have a few different ways we can implement snapshots into Unity. We've gone through 2 common examples we can use snapshots for. We've seen how snapshots in code are treated like any other event, making it super easy for us to implement them. We also know how we can trigger snapshots by telling them to start and stop, and control them with parameters. And with that, we're nearly finished with the entire course. Well done for getting this far and learning all you can about FMOD audio implementation. But now it's time for our final lesson. We'll be talking about a topic that's been hiding in the background a little bit all this time, way back since the event instances lesson. This will be about FMOD sound banks. So when you're ready, I will see you there.